And yes, seems like I am live and we can just begin. I did not stream for a while, but now I am back at it and we will do some crazy stuff in Advent of Code. And I guess it was day number 15 of Advent of Code. And no, of course, not 15, 7, 7. Yes, 7. And yes, this is the problem. This is the question that we have to do. And we went on to Reddit to see some hints about this, and we figured out that we have to store these instructions in a tree structure so that we can start from the root and start executing things from there, which is a crazy thing. Yep. Or or we have to or we have to store the instructions in the way, let's see, let's something we can use dynamic programming to solve this. And for that, like, let's say we have an instruction like this instruction. Let's say we have this instruction. Now, to execute this, um, we don't have to do anything with this D. Here we have D is the target, X and Y are operands. We can only execute this once we have X and Y initialized. And to initialize X and Y, we have to find the instructions in which X and Y are destinations. Like in this instruction, D is the destination. So we have to find instructions in which X and Y are destinations. That is instruction these. So first of all, I will find the instruction where Y is the destination, because in any given instruction, in all the given instructions, one wire can only be used as a destination once, and that is it. It can only take one input. Of course, it can only take one input, but its output can go to multiple registers, but it can only be the destination in one instruction, and that is it. So first, I will find the instruction in which Y is the destination, and let's say I found this, and this I will see if there are any operands which need to be initialized, and if there are, then I will find the instructions in which they are destination registers and move on. But in here we have an immediate value which is used to initialize Y. Thus I will just execute this instruction and initialize Y, and after I have mm, done with Y, I am done with Y, I will go into X and do the same for this instruction. And thus, after X and Y are both initialized, I can easily execute this instruction. And that should be cool. Now, the data structure in which I will be storing this. Well, first of all, there is the whole node structure. Nah, not node. Node, yeah, binary tree structure in which should I have a single tree? Yes, I can have a single tree, yeah, and in which the parents would be the operands, right? A single node whose parents will be the operands, right? And whose children will be wherever the destination wire is used as a operand, right? So in something like this, we should have, yep, uh, if we have something like this, then the structure should be like, we will start with the first instruction and we will, yeah, so you'll have to see, wait, Okay, so there are two things that I have to decide. First of all, how would a single node, individual node look like? And then second, how they will be arranged in the overall structure. So a single node will, of course, be something like this, which will contain operation, opcode, which will be an integer, right? And yes, and it will contain an in integer op1 hash or op1. It should contain operation 1 hash or op1. What will it contain? It will, what the fuck? What is it going to contain in the operands field? In the operands field, is it supposed to contain the name of the register, the name of the wire, the symbols for the wire, the two symbols for the wire, as a string, or the hash for it? I guess hash, hash, storing the hash would make sense. So integer, op1 hash, and yep, storing the hash would make sense. And same for op2 hash. Now, and the same for destination hash. Des hash. I will have a destination hash. Yep. And now I need to find a way so that I can go up. Given a single node, I can tell the parents and the children will. For children, I will have a list of arrays, a list of its a list of pointers, and number of children. Yep. Integer, uh, number of child, and the pointer, um, a node pointer, um, children, children. Yep. A list of node pointer. Yep, and number of children. Yep. And then this will give me the children for this node, which children mean the places in which our destination wire is being used, and do I ever need it? Would I ever need it? Yeah, I can actually need it. Yep, I can. I might actually need it. Uh, in the case that I am going from root to leave nodes, like root to leave nodes, and solving it progressively. And this is just the code for the instruction. You see the instruction, and then I will have parents. Yep, parents. An integer which will tell me about how many parents this has. Well, at most it can only have two parents, right? At most it can only have two parents because it can have two operands at most. So I will only use a char to tell me parent Uh, that is horrible writing. Parent count. See, parent content, no, count char, and then a pointer to store them. Node, that is just absolutely amazing writing. Node star parent. A, a, that is just horrible handwriting. This takes parent. Maybe I'm trying to write too small. Yep. Hmm. I got the instruction, child, and parent. And this is how each individual node will look. And now I will solve for this. Let's say I get this, and I see that X, the operation is initialization. And initialization operations are going to be root. Um, so I will do this. Let me number them: one, two, three, four, five, six, seven, eight. So at first I will have one node, and then I will encounter this second one, and I will see that this is also a root node. This is also a initialization operation which has an immediate value as an initializer. I will put it there in the top, and then I will discover this, and thus, and thus, thus, and then I will encounter this where I will see x and y as operands. So how do I make change to the x and y nodes to add 3 like this? How do I do that? And is this even required to solve this all? Hmm. Yes, I will have to, if I want to do this, then I will have to have a list which would give me a list, or maybe a structure, or an array of structures which would give me the address for a node whose destination, whose destinations hash I have. Like for 3 to insert 3 at a particular place, I know that the operands are x and y. So if I calculate the hash for x and y, I want a structure or something that will give me the address for the nodes x and y, so that in those nodes children I can add the third node, and in third node's parents I can add the first and the second node. So I need to have something which will give me the address of a node given the hash of its destination register. How can I store that? I can simply store the that as a list in a structure, as a list in a structure. Okay, let's say I have that function, and then I update the x and y nodes, the parent nodes, and I append the child, and then I move on. I move on, and I see see the fourth instruction, and I see the operands are x and y again, and thus I will do x. These both will point at 4. Yep, and now I get this, where this and this are the fucking hell. Uh, fucking F. So how do I store immediate values in an operation? Well, if the operation is like left or right shift or no, 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 no. So in the operand, I won't always have the hash. I might have an immediate value. I might have an immediate value. How do I deal with that if I have an immediate value? If I have an immediate value, if I do not have an immediate value, what will the hash do? Well, let's restructure the instruction part. Here, destination hash. Why am I storing the hash? Hash are used to hash into a table into an array which stores the current value that these things store, and if it is zero then it just stores zero, and if it is not zero then it just stores what this is. And yeah, yep, and I require opcode. I need just values here, not this, just values, just values. Putting just values there here would be cool. So I'll just put values, and I do not, it doesn't matter to me if it is immediate or what, it just has to be value. Right. So I will have to get the value at the time that this instruction is being created, but that is not possible because maybe the wires are used before and they are initialized later. Then yeah, I won't be able to do it. So instruction op hash will have to do. So there are two parts. First, reading the file, the instructions, and then executing them. So do I want to execute them at the time that I'm reading them? I guess not. Nope. So I will first read them, store them into a structure, and then solve them structurally. That would help me get to the answer. And now, what is the problem? Child node, number of child, and a pointer to every child node. That is cool to start solving from the root nodes and then going down is spreading everywhere. That is cool. And I will be using breadth solving to solve the first layer of nodes, then the second layer of nodes, then the third layer of nodes. That would be cool. Like in this, the structure would form something like this, 5, and then I have sixth instruction. Nope, nope, 5 does not do that. Um, 5 only takes x, and x is the first. So 5 comes here and it only takes this, and then sixth only takes 1, 2, and seventh only takes this, the first, and this only takes 8. Yeah, and how the heck? What if I get there is like, let's say, a third layer? This is the first, this is the second layer, and what if I, let's say, I get a third layer, and I haven't encountered any element from the third layer, but then I suddenly encounter an element which should go into the fourth layer, but I have not encountered any instruction to that. Not instruction, but I have not encountered any element, any of its parents wire yet. Any of the instruction which initializes their parent wire. So even after looking in there, I won't have any parents to link this to. What will I do? Let me just first of all only read this read the whole file, and yeah, read the whole file, create the nodes, and create a mapping from the hash of destination wires to their nodes. And initially, OP hash and OP1 hash and OP2 hash will have the hashes. Yep. OP1 hash and OP2 hash will have the hashes, and destination hash will also be there. Number of child will be 0. Number of children will be 0. Number of parent will be nothing. And pointer to parent would be empty. Yeah. And yeah, that makes sense. So, yep, that makes sense. And let me go AOC add of code 2015 ls cd day 7 lsn part1.c, and we had written quite a bit of code. And what the fuck is this? This is make move. Global active wires has been removed. Okay, so here I'm just reading and then calling a function called find a, which tries to do all the things, and it goes on and finds the move. Okay. And after find the move, I have to do some things. And what does the find move function return? It returns a move. What is the format of a move? Format of a move is this, which is just retarded. I have to have hashes for them, not a string pointing there. I have to have hashes, right? Their hash. But what for immediate values? Well, what for immediate values? Okay, I can just do this. Change this to an integer, and change this to destination hash, something like this, and then integer op1 hash, and then integer op2 hash, right? And that makes sense. And I can say is op1 immediate? That is op1 immediate. If it is immediate, then I will have op1 hash contain the value, the immediate value char is op2 immediate. Too many errors emitted. Stopping now. Right, this, and I will have to do something with this and change the find move function. Find move. Here we have find move, and in this part I am getting the opcode, which is pretty cool. And here I'm getting something, and here is my hash instruction at the end. This is my hash name, right? It just takes in a char pointer, character pointer, and second char. Let me just change the implementation and make it not be a retard. Char string, and I expect to get a null terminated string. Yes. Do I expect to get a null terminated string? Yes, I do expect to get a null terminated string. So in um, base 26 equals 0 initially. Now for int I equals 0, I less than or s si is not equal to null. I will do I plus plus, and I want to change this base 26 into the 26 base value. So I'll do base 26 base 26 into 26. Is that right? Um, is that right? Nope. That is. Wait. If I have a number, let's say C, D, I will have C equals 13, A, B, C equals 12. Does it? Yep, it does. C equals 12 and D equals 13. And so I will have 13 multiplied by 26 power 0, and then 12 multiplied by 26 power 1, and then add them. So do I start I at from the end, so that fuck, if I start at I from the starting, then I need to know the power, which I will not know until I encounter the end. So I will have to start at the end and then multiply and add, multiply and add. Yep. int I, right, int I equals 0 and go on. So this should give me the length for it, and I will I that is I for this I will start at 2. I will end, I will be equal to 2 at the end of the loop. So now for now I know the number of digits, which is 2. So the power will start at 2 minus 1 and go till 0. So I can start a new thing called j for int j equals 0 and till sj is not equal to null. I would like to do something. I would like to j plus plus and base 26 plus equals the current character for this iteration would be sj minus 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 sj, where a means a number that a minus a, where a means 0. Fucking hell. A has to mean 1. A has to mean 1. A means 1. I do not have any 0. A means 1. Fucking hell, I do not have any 0 in my counting. That is crazy, because I want to have AA and A be not equal. So AA will represent 26 plus 1, 27. This is the value for the current number. This is the value for the current number. Now I want I want to multiply this value by power 26 raised to the power I minus j. Is that correct? Nope, I minus j minus 1. Is that correct? Pretty much seems like it. And I can just do that. Yep. And then at the end, return base 26. Yep. So hash function is good. And this just takes in a thing and converts it into ATOS. ASCII to S. What is S? Short. Why do I need to convert it to short? Short. Ooh. Um. Okay, so when there is an immediate value, I am converting the thing to short, and yeah, because the maximum value that it can take is uh, unsigned short. Yep, U short, and number starts at 0 till it gets to the null character at the end of the string, and yeah, that is cool. That is cool. The hash function is cool. Now for find move, I have to make some changes in the find move function. I got something for the destination to store the destination, and yeah, that is cool. And I also changed the format for the move, right? Yep, I changed the format. So should I make it find move or find node? Find move would be cool, would be much simpler, and then I can find node in given a move. I want to create a node for that move. That is a that seems like a good design. Now in this part, I am getting the opcode. That is cool. And then I am getting if opcode equal 5. That is, it is not. The operation is not. In that case, I am making op index is my stream lagging. It might be lagging. Well, no. The dropped, it says that a dropped frames is 0. So that is cool. Now, how, how much time has it been? 30 minutes already, and I feel fucking sleepy. But whatever. When operation is 0, okay, I am initializing I, and then I am doing something. Right, right. I initialize I at 0 and go and went at 4, which means I started going through the line after the fourth index, which means that I will start at the register, and I will add the register or number, whatever it is, to the operand thingy, and I will put at the end of the operand 0, 0. Yep, I will put 0 there at the end of the operand, and then target equals 0, which does not make sense. Which would make sense if yeah, that is if target, that is I am currently at the destination and I am encountering numbers and characters, then put that into the destination register, put 0 there. Yep, and move dot destination hash equals hash name and give in destination. Yep. I gave destination, I gave the opcode. Now I need to give the immediate value. Hmm. I need to give the operand. Now I need to check if the operand is a number or what. Have I put \n at the end of the operand? Nope, I have not. Operand op index op index equals null, right? And now if 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 op index is 0 is a number, that is it is less than equal to or maybe greater than equal to 0, and OP index 0 is less than equal to 9, less than equal to 9, then I know that it is an immediate value. Then I have some special things that I would like to do. First of all, I will make move dot is op1 immediate equal to 1, and move dot op1 hash equal to hash name and pro, not hash name but um um, um atos and provide an op and operand. Subscripted value is not an array pointer or vector. Oh, do you? What is the subscripted value? Subscripted value is 0 in both the cases. So, not index, not index. Go to check and check the operand, not the index. Yep. Yeah. Else that is an op1 immediate equals 0. It is not immediate, and move dot op1 hash equals to hash name, provide in the operand. Yep. Yep. And then just return move if it is 5, right? And if it is anything else, then malloc, right? And did I malloc here? I did. And thus before returning I should do free, or maybe, yeah, I don't even need to do that. I can just do this. 50 characters long array, immediate array, and yep, and here also I can do operand 50. Okay, operands, that is also working, and null equals 0, and then I get some things in the operands in op1, and operands. This string contains the operands. If there is if I have a character or I have a number, I will put, and I am into operands, I'll put that into operands. Else if I have a capital or a small thing, then I will make null equals 1, and I'll put a space. All right, I will put up a space. Yep. And yeah, and yep. Null equals 0. Okay. And when I reach the destination thingy, I make in op equals 0, and if in op is 0 and I am encountering a character, that means I am inside operand destination. Now destination is always going to be hash, this hash um equals hash name, and it takes in destination. That is cool. Now I want to do something. What I can do is get op1 and op2 separated, and I am inside ops, and one more thing, and if it is null equals 0, then add into operands 1, operand 1 and operand 250, and if wait, I can check for this inside this, right? If null equals 0, then do operand 1 op1 index, that is what I will need. op1 index plus equals si, else if it is not null, then do operand 2 op2 index plus equals si, and let me change this to op1, yep, op1 index and char op2 index starts at 0. Yep, and then just fucking remove that, doesn't matter in the slightest, and put up a space, nope, not required, and this does that, that does that, and this does that. Yes, yes, and now I will have operand 1 on this, but op1, not op1, op1 index, and I will have operand 2 op2 index equal to backslash null. Alright, I got that. I put null. Now I need to find out if they are immediate values or registers. Right, and if first I will check for operand 1, if op1 0 greater than equal to a, and at the same time operand 1 is less than equal to z. If that is the case, then I know that it is not an immediate value and it is something yeah, 0th. It is not an immediate value and I will have to store the hash. So I will do op move dot is op1 immediate equals 0 and move dot op1 hash equal hash name and give in operand, and else do move dot is op not op1 immediate equals 1 and dot op1 hash equals atos and given operand 1. Now I will want to check for operand 2. Oh, that is retarded. Operand 2, I'm not getting any correct meaningful auto suggestions. Operand not 1 but 2, 0 less than equal to z. If that is, then do move dot is op2 immediate. Nope, it is not. And do op2 hash equals hash name hash the operand 2, and yep, and in the else part do op1 is like in this case it is an immediate value, then I will make op2 hash equal to ATOS operand 2. Yep. Does that fill everything that can be or should be filled in this? And what if it is initialization? What if it is 0? Fucking hell. What if it is 0? The instruction is 0. Well, if it is 0, then I have a separate thing operating on that. Don't do that. Do char, not, yes, char operand again 50 characters you did. That doesn't matter. And yep, define an immediate array. I will only have one operand in here. Start at 0 till the end of the instruction, and if I have a character or I have a number, and if I am inside the operand, then I will do operand op index equal to that, else, else, else. If I'm not in the operand, then I will do destination. I'll put equal to destination, yeah. And yes, and destination this hash equal to hash name destination op. Yep, I have put in op. Now I need to find out if it is. I'm making this call quite a bit, so I can, no, I cannot, yes, this change this to if operand 0 less than or greater than equal to a, and operand 0 is also less than equal to z. That is I z. That is I have a wire instead of an immediate value. Then I will make move op 2 equals 0 and move dot op 1 hash equals to hash name and give in the operand thingy, and else that is it is an immediate value. Then move dot is op1 equals 1 and move dot op1 hash will be equal to ATOS, and it will take in the operand, and here we are, move dot, yeah. All of that is done, and in the end I will return the move. And what the fuck, I'm so fucking sleepy. So the new refined move function should find the move, and I can just fucking delete. Yeah, I can just fucking delete the make move function, which is going to be totally implemented in a totally new way. Yep, find move, not make move. Don't make any moves. That is bad. Now I want to print this. I want to check if I'm getting the right thing or not. Then let me, after getting that, do something. If op equals 0, no, print anyway, doesn't matter if it is 0 or not. How am I supposed to do it? At the end I'm putting a new line, and before I am putting s line, okay, that just prints the line, current line, okay, and then I have operation code, opcode, and then I have not destination, that this is a number, destination code, destination hash, and I will have operand hash and all this stuff, okay. This hash and yep, this and hash and I have is OP1 immediate and a number, a hexadecimal number, and OP1 operand 1 and a number, like a legit hash or the number itself. Then I will have is OP2 immediate. It will be represented in hash, and then operand 2 becomes equal to percent %d, and then new line at the end. And after destination hash, I have move dot is op1 immediate, and then move dot op1 hash. Okay, yeah. Move dot is op2 immediate, and then move dot op2 hash. This should work. Yeah. Golang part1.c dot out, and it does compile and it does print a few things. A few things. A few things. Char, this is unsigned char. IGNAT. And why am I only getting these few values? Well, that is totally horrible. And this is unsigned, by the way. This is also unsigned, and this is also unsigned. Nope. Nope. What the fuck is F1? Why am I? Okay, operand 2 can be whatever it wants to be in this case. When opcode is that. Okay, okay. I mean, 4 cases it was this, and when it was 0, I had 24, 25, 24 means X, and 25 means Y. That makes sense. I guess I had destination. I got 4 for D because A means 1. That is also cool. And 5, 6, 7, 8, 9. Yes, that is cool. And that is cool. This is happening because of I'm using test here instead of text. And for test, I will have much bigger things. Okay, that is a cool way to represent instruction or shit. For this thing, let's say I got opcode 5, destination hash is 277 227. The first is not immediate, and the second does not even exist, so I don't even have to care about it what it is. It is just the same what it was for the last one. So if I see operand 1 being same for 2 things, then that means for the current one I got a not, and before it was not. Yep. And for not, yep. I see. It is remaining same because not does not do anything with the second operation. It doesn't do anything with the second operation. Operand. Now, after getting the instructions, what do I want? I want to create a node with that instruction and put it into some global array which I can, if given the hash for, I want to create a node and put it into a global array of structures if given the hash for a destination where I can find the node in which it is initialized. That is a cool thing. And if I can do that, then I will start linking the nodes. Yep, and create the tree in the next step, and then after creating the tree, I will solve it. So now, first I have to create the node and global state. What the fuck is global state? Maps a hash to its value, right? Given the hash, it maps that. I can do um uh move no node. Okay, let me do a node type def struct. Fucking hell. A few. Okay, it will only have at max two parents. So parents can be a constant thing, but the later part can be a bit longer. Okay, okay, I will store the pointers for the children nodes in the heap, and to that, the array containing the pointers for the children will be stored in the heap using malloc, and a pointer to that thing will be stored in here in the node. So first of all, it will have a move. So I'll move and move right, and then this is going to be the move part. Port, port. Yep. Character. A character will be stored. Child number of children, and then a pointer. Well, before children, let me go to parents. Um, yeah, a parent will store no uh, struct node pointer, a pointer to a structure node, a pointer to a structure node. It will be called parents, right? And it will be called node after that, and a pointer to the structure struct node pointer children, a pointer to a children node, and the array list will be stored in it in the heap node. I have defined the structure for a node, and now I would like to, after getting the move, I will like to call a function which can create a node and update the global nodes array. Like here I have this, and this will other thing which will be stored. Pointer to nodes, and nodes themselves will be stored on the heap. Well, they can be stored in the stack, which is okay, but let me just use the heap. A node pointer which will store the pointers. Mm, yeah, pointer array, and not an array of structures, but an array of pointers of nodes. And I hope, yep, not I hope. Shit, it is lagging. It is lagging. It is fine now. Now it is cool. Yep, it was lagging at some point when I was not paying attention. Now, node. This array has to contain pointers to nodes. Now, the name, which is very difficult. What can I name it? I can name it node, node hash table, or nodes hash table. Not a pointer, it is a pointer of pointers. Like I might have up to 800 nodes. That is just for safekeeping. Now I want to create a function that will take in a move and create a node for that move and put it into the put it into the array above, yes, into the hash node table. This will return nothing. Yes, this will return nothing. Uh, Create node, or more like initialize node. It will take in a move and do its thing. What is it supposed to do? It has a move, right? So malloc, first of all, malloc. Right, a node pointer called node c node equals node pointer of malloc and do size of node. I got some space. If c node equal to null, then just return and do here printf node full. Um, oh, Memory full, not node full. That is stupid. Oh, ah, that should be cool. Ah, that should be cool. This function will just return in that case without making any changes. But if it does get some space, then I will do node dot move equals move. Well, the move that I am. Okay, what does this do? Node contains a move. Nope, it can. Should it contain the move itself or a pointer to the move? A pointer to the move would be good. Yeah, would be good. And where will the move come from? Move will come from some upper context. Is the move malloc? Let's see, when I am creating a move. It is in the find move thingies content context. So I should malloc. If I malloc and get some space in the heap for the move, well, first of all, I would like to free the destination before returning. That is just something I can do. And let's say I do malloc. The move is from it. It is from there, and I will write. I can write a function which will free all the moves at the end. So let me just do move as this as a pointer to a move called move equals not directly malloc but move pointer malloc size of move. What expression did you expect? Equals move pointer malloc. Move pointer equals move pointer, a pointer to a move malloc size of What is the expression that you are expecting? You are expecting some expression here. Why the fuck are you expecting any expression there? With that is okay. I can do that. I can do that. I can do that. Return move. Oh fucking hell! It returns move, not a pointer to a move. So wait, but it returns move itself. So, but the move is stored onto the stack. So when it is returning move, the stack point stack loses it from the stack, and when it is returning, so is storing it not on the stack but on the data section of the memory. Memory. Huh. If that is, then I can simply let it live long enough to see itself become a villain. That is cool. Uh, here inside the node, I am storing the move itself, and here I got a move, right? This. Go to the move and make its value equal to move. Why did it even use this? Struct node pointer. Okay, I have a pointer to a node. Yes, I have a pointer to a node. Go to go to the node and there put move equal to this, the move that I got, and then see parents and child num. Child num is like initially equals to this to 0, and C node is also initially equal to 0. What is the main purpose for this thingy? The main purpose for this is, yeah, C node, this child num equals 0, and C, and that should be enough. That should be enough. That should be okay. And I am storing pointers. So, let me do C node parents equals 0 and C node, I will make them null pointers equals 0. After in this step function till so far I have initialized a node. Now I have to put the address for this node into the global hash node thing, node hash table destination. Yep, hash name. I already have the hash for the destination in move dot this hash equals c node pointer. Yo, that should do it. That should actually do it. As far as the functioning for this function is concerned, So I can, after getting the move like that, I can call initialize node with the move. And now, after doing that for all the nodes, I would like to, yes, after calling and doing that for all the nodes, I would like to do a little something. I would like to print the global node hash table for int I equals 0, I less than 800, that is the length for the hash table, and this will give me a node if it is 0, that is nodes hash table I equals, or if it does exist, then this is the way that I would like to print it. If it does exist, then I have a pointer to it. If I have a pointer to it, I can go to it and retrieve things. First, I can just simply print that like that. Uh, yeah. Go to nodes hash table bracket ith node. Go to move and do this. Okay. And now I have to print the same thing over and over. Oh no, no. Print this here, here, here. Right, right. I have printed the node, and what else would I like to print? That should be it. That should be about it. Clang.catch out, and that is a little. No, that is okay. That is just absolutely fucking amazingly fine. Okay, so destination starts at 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 12. Goes up, goes up, goes up. I have quite a bit of destination registers. And yep, till 339. Okay, so I have created the nodes and stored the pointers to those nodes in a global hash table array, whatever you want to call it. Now I need to arrange them into a branch structure. Let me wash my face. That would be cool. But just before that, here I did the initialize node, and after going through all the nodes, I would like to do a little something. I would like to call a function which would return void, a function called create tree. Uh, just that is it. So fucking hell, tree will contain what? Yes, this will return something. This will return a pointer to an array. Yeah, okay. This create tree function will return an integer pointer, integer pointer, an integer pointer, and it will take in nothing. And that integer pointer points to the first element in the array, which contains the addresses unsigned int, uint, unsigned int into uint. That is more like it, and type def unsigned char into u. char, more, you, uh, un, unsigned char equals more char, browser, above, and change this with, ah, change this with you, change this with you, change this with you, this with you, this with you, everything is with you, and yeah, this can be okay. Move, I got move, right, and I got a node pointer array, void returner function, unsigned integer hash returns u sign, and this returns the value of a, which is unsigned, and this returns an unsigned thing. Create table, find a. Are there any errors? Yes, there are. Unsigned. Are there any other errors? There was. Nope, there aren't any errors anymore. And in our main function now I'm calling create tree, which returns a node, an integer pointer, roots. It'll just be called roots. Ah, it will return a pointer to an unsigned integer. And what is that integer? Return a pointer to an unsigned integer. That integer is the hash. Yes, that integer is the hash for the node, for the root node. Okay, okay, okay. And I also want the length of it. It's length. I also want the length, the number of root nodes. So type def struct. It will have character unsigned u char length and an integer pointer hash. That is just pathetic. And what do I call it? I will call it root create a tree return type, and that is what the create tree function will return, which is right here. Create tree return type, and I will make this not equal to this, but create tree return type gets that, and we now I will do the create tree function. Create tree return tree create tree does not take in anything, and yes, it has access to the global thing. For every node, for int I equals 0 till I less than 800 I plus plus. Now, if node hash table I, if it is, then do something, and then do node equal nodes hash table I. With that is a pointer, and I am assigning a pointer to a, not so much as a pointer. So let me make this node pointer. So I have the current node, and to create a tree given a node which is like this, I need to update its child and parents based off of its operands and destination. And let me just go and wash my wash my face, and I will be right back. And maybe have a little bit to eat and drink water, of course, water. Yeah. Yep, I am back and we are going to create the create tree function now. And I also have my second channel if you want to subscribe and support me on YouTube. Go there and just do something to my second channel if you want to. Have to somehow. I don't know why you would have to, but that is it. Yeah, I got the node. Now I do not have to do anything with the opcode. I just need to update the children and parents. And parent. In the parent, I need to store the hash. I need to store the hash. Yes, hash of the parents, which is cool, which I don't even fucking need this. No fucking hell. I don't need this. I can do all of this in the initialize node function. Yep, right here. In the parents and children, I need to store the hash for the node, not the address of the node. If I do the hash, I can translate and get the address of the node from there. Yeah. Nah, nah. Nope. 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 I need to do the create tree thing because I will have to update other nodes. When I get a node, I will have to update the parents of the current node, but I will also have to update the children of the node above it, children of the node of the current node. Do I need children? Yes, I do. When I am solving the tree, I will have to have children. Yeah. And before going through this, all I will initialize also um someplace hash hashes hashes hash. I will initialize hash. Well, at least in this one, I can initialize in the initialize node itself. Yep, I can initialize this in the initialize node function itself. It will just contain. Let's say it will contain uh, an uint pointer parents equals uint pointer malloc 2 into uint 2 into size of uint and then parents, the first one will be equal to move c node. That's not c node, but move it. Move dot op1 hash and parents one will be equal to move dot op2 hash, and I will make this equal to parents. Is that amazing? Okay, I am saying that parents point contains the node pointer instead of hash pointer instead of the hash, so I can change the node structure of the node. Is this node? Nope. Is this node? Yes. So instead of pointing to a node, this will contain the hash, and that is unsigned integer pointer. And same goes for children. Nope, children, I will be initializing in. Forget now. It is good to have a decency, so you int pointer, and I will not be able to read this code after, I guess, even after a few weeks, because this is so horribly being written in the current time. Yeah, yeah. It is equal to parents, and yep, I would also like to print again the whole thing, the node and the everything thingy thing. Create this, do this, and also print parent one hash hash. Yes, parent one hash, parent one hash. Yep, parent one hash. It is a digit, and parent two hash. It is also a digit of sorts. And now here will come node hash table I, not move, inside move, not don't even go there. Parent zero, and then nodes hash table I, go to parent one, and well, actually print two new. Nope, one is fine enough for us humans. And yes, I have not completed the implementation of a function called create return type. So what I can do is this return nothing but comment this out. Nope, clang it and run it, and am I getting parent nodes? Yep, I am getting parent nodes. This is fine. So what is operand 1, operand 2? None of them is immediate. Okay, operand 1 is immediate and it is equal to 5. Okay, in this case, none of them is immediate and destination is 3. I'm finding the not, therefore operand. Okay, none of them is immediate, and operand 2. Parent 2 hash does not really matter in this case. This is a shift operation. That works. Works. I wanted to see some operand, actual operand value. Yep, here parent hash is this, and operand 1 is also hash. This is 69, that is 69, that's cool. That is cool. And if that is cool, why do I need parent at all when I can get the hash from move? Well, syntactically it looks good, I guess. But if I want to make it like a standard thing, then I should not mess around. Yes, let's say there are 10 initializations operations, which there surely are not. I will just told you that let me do calloc this time. Um, it will be a pointer which stores unsigned integer pointer called roots unend pointer malloc calloc continuous allocation kind count. I want 10. What is the size of one thing? The size of one thing is inside of unsigned int right and char root index starts at 0 and this is uchar by the way. And yep, now I need to see if it is an initialization with immediate value. If it is with immediate value, then it goes in here. If node, if node, nope, it goes in here. If node, if if node, go to node, move dot op equal 0, right, and node, go to nodes, move dot op1 is op1 immediate. If it is this all, then I'll do roots root index plus plus equals the hash for this comes at the top, which is the hash for this is just move, not move, node. Dot parents, nope, move dot destination hash, yo, destination hash, yo, yep, that makes sense actually. And if it is not, like if it is just any ordinary node, then I will have to put it into the tree somewhere. And at the end, let me do not move, but create tree return type, a thing called return type, which is supposed to be returned itself as it is, and now return type dot length equals root index and return type dot hash pointer equals roots and return type. That is just crazy maths. Now I need to insert a node, and in order to do that I need to find the parents, which are only two supposedly, for the current node, and update their child. Update their child. Update their child. Yep, update their child. And how? Oh, and child is an array of unsigned integers, which are the hashes for their destination, which just can be just an interface, Rosetta Stone, to get the address for the node, which is stored in another global hash table. I can use the hashes in the child array to get to the node of that, to get the node. for that in which that child is being initialized. Right, now I want to get the address pointed to the node, hmm, the parent, and parents might be one or two. Yes, parents might be one or two. When I am initializing the node, I'll do this. I will just do this. Parents is parents. Op1 hash, op2 hash. Fucking hell. How would I know that I have parents? How many parents I have? So I'll just also do change the node structure to which will also now continue char parent num, and now all hell breaks loose. Oh shit, nothing broke loose, brother. And I'll do if moved on is op2 immediate. If op2 equals 0, if op2 is 0, then that means both of the parents exist, and I can just, well, I was going to do that in any case, but if that is true, then I can make c node dot parents num equals 2, and now in here this will help me. Now a parents parent what the fuck, and nope, I want pointers to nodes, um node pointer parent 1 and node pointer parent 2. Yeah, use of undeclared identifier. Okay, it is happening because of this. Yo, don't do this then. Do this. Do this. Do this. And yo, yep. And do this. And here. If C node dot parents num. If C node dot parents num equals 2, only then will I get the second one. Parent 2 equals nodes hash table, and given the hash, where is the hash for the second parent? It is in the C node dot parents 2, and I will get for parent 1 anyway, like no matter what. C node dot parents yeah, 0. Replace this with 1. Now here I have the nodes, the pointer to the nodes of the parents if both of them exist, or depending, and well, I will have to update the first parent anyway, and then I will conditionally update the second parent. So this part can go fuck itself. Well, that is abusive, but it can wait. That is more civilized. Even though fucking is a major part of the civilization, without it, there is no civilization, right? Maybe it is all about dicks in the end, like someone said. Now, I got parent one. I need to work with the node. I want to update the children. Update the children. Yes, that makes sense to say that. Go to parent one dot child num. Now, depending on this, I will do a couple of things. If child num equal to 0, right? Then I will have to initialize something. Initialize a malloc and do as a malloc and do some things. Um, an int pointer child equals equals an int pointer malloc size of an int, right? And do parent one child number equals 1 and child equals what, go to the thing at whose pointer you have and make it equal to the current node hash. Yes, um, that is the the right. That is c node dot move dot destination hash. Yes, is that actually a yes? Yes, that is actually a yes. And then else, not like that. That is stupid. Else, else, I need to get the size. I know that the size is not 0, that is there are already children and I will have to add to it. For that I will malloc a little bit more than what already is the size of the children. So parent one dot child num plus plus update increase it once and pointer children this time multiple equals unint pointer calloc, and the thing is parent one dot child num and size of unint undeclared identifier children. What the heck? Undeclared identifier children. Have I used children before in anything? Nope, I have not used children. I'm initializing children here. Unint children equals this. Pointer to an unint is children p use of undeclared identifier. Yes, that is what I'm doing here. I am declaring it. It is an unint pointer. Fucking hell. The stream is going smoothly. Yeah. What is the problem? So do I have to declare it and then get a pointer to it? No. I did this right here and there was no problem and they are the same. And here I am getting unint Oh, unint is unit, not unit. Uint. Oh, there was a spelling mistake. Okay, I got the children. Now I want to do this like afterwards at the end. And so here I can do uh, here +1, children +1. It looks more sensible and readable. And in here I will do what will I do? I'll have to copy parent I equals not I has already been used. Parent j equals 0, j less than parents 1 dot child num j plus plus, and do children j equals the already available list of children, which is in parent 1 dot children j. Yes, I got the latest children. And then let me do children uh, parent 1 child num equals the latest one, the current one, c node dot move dot destination hash. Increase the number of children and update the parent one. Well, first of all, I would like to free uh, parent one dot children, which has been malloc, and then parent one dot children equals it will point to the new children. That should be it. Is that actually the whole? Well, that is just the part for the children for the first parent, and now for the second parent. I will get this and more or less copy paste this. If parent number is 2, that is I have 2 parents, which generally I should have not like I do have it depends. I will make this equal to 2 child num, and I will make change parent 2, yes, and yep, and yep, I found a mistake. That is in here parent 1 should eventually, not parent 1 itself, but parent 1 dot children should point to child, like like any normal human being would start to point to a child. Yes, just do that with the child and you will see what I'm talking about. Do that and replace that. Yep, and replace that and yep, replace that and yep, replace that and replace that, replace that. Yeah. If there is a second parent, then update its children and well, update the first parent anyway, because I know that this is not an initialization thingy, right? Initialization nodes are dealt with here. And just this. Well, let's see if it at least compiles, which it does it run, which it does, which it does. I would very much like to call upon the stage this function. We'll be calling this afterwards, and let's see if I do get any errors. I do not. Then- Which means it might have actually worked. And now I would like to print the tree or the hashes for the root nodes, right? Hashes for the root nodes. Mhm. Print the hashes for the root nodes. Yeah, print the hash for the root nodes, which is just root for int I equals 0, I less than roots dot length I plus plus, and then printf root hash is %b, and then a new line, and the root hash is roots dot hash 0, and just don't do that, and clang dot slash out 2, which means p is initialized, but so was c. C was also initialized. I should see it when destination is 2. Yeah. First one is immediate, which is this. Second one is also immediate, which is just happen to be equal to 5. And it should not have. And parent hash is that, and that is that. For third destination, it is 0 and it is 5. And I should have seen 3 there actually. Destination 3, hash 3. I should have seen 3 there. Why did I not? There is a mistake with the create tree function in this part. Well, yeah, I'm only checking this part. This part actually. Roots, roots, making it equal to the destinations hash. This should do it for when the destination hash is 2, and when the destination hash is 3. This should work in both the cases. Just recompile and run, but it is not correct. I should see 2 separate things there. I'm getting a pointer, right? Yes. No, the roots variable is not a pointer, it is the root itself, and in that I'm going to hash. Because I am a retard. Let's function it. Now, well, that is done. I have created the tree. Hopefully, I would like to print the tree. How can I print the tree? Child. I will take a node, go to its child, and print the hashes for all the childs. Right. For int I equals 0, I less than root dot length and I plus plus, and inside I'll print the root first. Printf root hash %d new line, and the root hash is roots dot hash I. Right. After printing the hash and the root, getting to the new line, I want to start printing the children. So I will do get a node pointer root node equals node hash table. The hash is roots dot hash I. Right. I have a node pointer now for int j equals 0, j less than root node dot child num dot child num. Yes, and I plus plus j plus plus, and now yes, I have to print the current child, current child's thingy. Printf, print a tab, let's say 2 tabs, that is cool, and then child hash, which is %d, and then a new line. What is the child hash? Child's hash is root node dot children and go to j, not children but dot j is just the fucking hash, is a hash. So I will get a hash through that, and that is what I want to print. Yes, hash is what I want to print. Expected this. Why would you expect that? Ah, yeah, this should work. This should work. Yes, should work. Put char new line after I have completed printing a root. Let's see. This is being used in 4, 5, 6, 15, 16, 22, and C is only being used in number 20. I can make this recursive actually, and write a function called, and this returns nothing, and called print pre, which takes in the number of the indentation, char indent, and root hash. It takes in a hash. Yes, yes, it does take in the hash. Yes, unsigned integer hash. Now, first of all, it will print the number of indent. It will indent it to the amount of space that it should be indented for int I equals 0, I less than, or it may be even equal to, because indent will start at 0, I plus plus, do put char, start just putting tabs there. After indentation, I would like to printf hash %d and then new line. And what is hash? Hash is any just the hash. And now I want to call this function for all of its children. Yes, now let me get a node pointer. Node equals node hash table hash, right? I have a node pointer if node dot num greater than 0, only then do print it. For int I equals 0, I less than node dot child num less than, yeah, and I plus plus. And for every child I will call the print tree function with node dot children bracket I. That should do too few arguments. Yes, 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 yes. Indent plus 1. Yep, and oh yes, do not call this like a function. Call this like an array. Yeah. Do that, do that, do that, do that. 35. Write this thing here. Yes, I do not have to rush. I'm fine. Find A, and here I was printing it originally, and I can just do it and call not create tree. I want to call the print tree function for every root, for which for int I equals 0, I less than roots dot length I plus plus, and print tree. Indentation will start at 0, of course, and the hash is just roots dot hash I. I'm hoping it works. Well, it is compiling and it does not stop. Ash, not hanoi.js path. So it keeps calling itself because the thing is interconnected. Because the thing is interconnected, so it keeps calling itself again and again. Okay. So it keeps calling itself again and again. Okay. Let me just use instead of print tree. Yes, why was it printing ash instead of hash? And here, instead of doing this with the text, let me do this with the test thing. Dot slash out, and 24, that is x, is being used in 4, 5, 6, and 8. And 25, which is y, is being used in 4, 5, 7, and 9. So we are getting somewhere. We are getting somewhere. And for our main tree, it was print going on again and again because This should not have happened. It should not be a cyclic thing, right? That actually should not have happened. It is like it seems very cyclic. Is it? It is not cyclic though. Yup. Hash. I got this. And where is the H? H is there. Okay. Why am I getting this many hashes? What the fuck? Hash does not make sense, does it? No. I got so many hash. Then it came down to 0 at 42. And here at 126. And here I have 41, 42. I don't know what the fuck is happening with this. It should not happen though. With test or with text, whatever. It should not happen. So there is a mistake in there somewhere. Let me just say that it will not cross, blah, 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 blah. Indent, if indent greater than or equal to 10, just return, don't do anything, not slash out. And okay, it does not exceed the number 10 and it does end somewhere reasonably. I got hash 2, which is being used in 4, and then 4 was being used in 14. Okay, and then 14 was being used in 15, that was in 18, that was in 19, then in 21, 24, and 21 was only being used in 24 was only being used in 24. Okay. Okay. Okay, I want to go layer by layer then. Yes, I am doing DFS, but that seems a bit wrong. So I should do DFS here instead of DFS. Print tree, it takes in a root, prints the current one, and it does not have access to the thing. It does not have access to the thing, to the thing, to the thing, to the thing. It will have for BFS. Yeah, or I want to print the tree layer by layer. So first of all, I will get nah. DFS is good. DFS is good here. If I do BFS, I'll first get the layer 1, then I will get layer 2, then I will get layer 3. That is also cool, but I will not know the connections, which is okay. This is okay. Yeah, I can print the connections, right? The children. Yes. No. Yes. One thing will have the same thing as children twice, so printing it layer by layer would be cool. Would be cool because one thing can have two parents. That is not, that is something just crazy. Now, sure. I want to print this tree layer by layer, which takes in a hash. So I have taken in a hash, and I want to print. First of all, I will get the node pointer, node equals node hash table. For this hash, I get uh, for this hash, it is because of the definition in here for print tree. Remove this. That's cool. Print tree. Yep. I got the node hash for the node. Now recursive. I don't think BFS in this case should be used as recursive. So I'll just BFS. I'm going to use an array which will be appended. Again, one node will point two different nodes can point to a same node. So when I am appending to the array, that same node can be appended twice, which is fine because I can use that. Actually, use that. I will. Okay. So what I have to do is at least I got a hash, which is just a crazy thing to get. I should get a. Let's say I got the root, which has some children. So I want to print the hash of the root, which is okay. Printf hash %b new line, right, with no indentation, and do just print the hash. Now I want to print every children for this, to just print the child's children with some indentation. Yes, with some indentation, with one level greater indentation than this one. And after that, call the print function, where I will be using those as root. No, so I should not print the hash. I will only print the root. I will only print the children. Okay, if I get a thing, then I will only print the children. Yes, I will only print the children. Yes, I will only print the children. And wait, what? Why did I do that? Yes, this int I equals 0, I less than no dot child num I plus plus, and this will take in an char which will tell the indentation for everyone. First, I will put the end I less I indentation less than indentation end plus plus, and do put char uh, tab. Now after the indentation, I want to print the hash for the current child. For that, printf hash %b new line, and the hash for it is no dot child I. Right. I have done that. Printed the child's all the child or the current node. Now I want to do a BFS. That is fucking crazy. I want to do a BFS, but this would just do a not a BFS. This would I have printed the all the children. Now I want to print all the children's children. This would just return. This would just mean DFS. Now this is actually BFS. Yes, because I have went through the whole layer for the root. I went through the whole layer, right, and then I will be going through the layer that through then. Well, yeah. This is not right. This is not right. I need to have a connection of sorts. Uh, Array to do BFS and just printing it. Yes. And printing it in correct order in BFS is necessary. Why, you ask? You might ask. Printing it in BFS is necessary because that is how we will be traversing through it when we are solving each move. So I have to write some BFS code where the parent can be 1 or 2, which is crazy. Okay, how do we BFS in something like this? Let's say our thing is this. Our structure looks like this. I have two root nodes, and this is like absolutely fucking beyond the top crazy. Yes, this is like actually fucking beyond the top crazy because the structure is a graph, directed graph. So storing it into a tree is does not make sense. Is not making any sense. Yeah, I'm storing it in because the structure can be like this. Say this node is here, right? And then I have another node 4, which takes this as parent and this as parent. This one takes these two as parents, and then I have a node 5, which takes this and this as parents, which is just crazy. So this is just a directed graph. Yep, this is a directed graph. And yeah, this is a directed graph. How so the main thing here is traversing. That is doable. Well, at least I have the structure. Now the main problem is traversing. I can do is first just execute the root nodes. I can just first execute the root nodes, and I want at the end to find what is the value for a particular wire, and I will thus see the function, the node which contains the move that initializes that wire, and I will backtrack. What do you call it? Let's say I want to execute the move for this node. For that, I will see its parents, right? And I will execute the move for this to initialize this. But first of all, this is dynamic programming, so I will have a memory array where I will store. So if this has been solved or not, yes, and if it has not been, then I will go to its parents, this and this, so that I don't repeat things. Right, right, right. And that way I can just print this how I was printing it before, just like that, just like that. But let me create a memory thing. Global state 100, yes. You char initialized state. It will have 800 elements, and let me just do that. This all will initially be equal to 0. I want that to happen. I can do this equal to 0 just by this. Now all of the elements are equal to 0 in that. Print tree, yes. If initialized state hash, if it is 1 equal 0, 0, only then do all this stupidity. Otherwise, and yes, of course, and not at the end, but just after printing. I can remove this command. After printing, I'd like to do in initialized state hash equals 1, so that I do not have to print it again, not slash out, which is again crazy and should, well, it did end at one point, which is cool. So that is just how it is. Hash, 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 boop, 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 boop. And these are all at one level, I suppose. And one thing is only printed once. Should be only printed once. 3 is only being used in register 20 and wire 20, and 3 is D. So what means is that this all means is that I will be solving the left ones first and then the right ones. Like to solve this, I gotta solve this, and to solve this, I gotta solve one of the thing that is left to this hash, which is okay. Okay, 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 okay. Okay. The tree is created, not tree. The graph, a directed graph is created now. I just have to write a function to solve it and fuck, right now I am in a like literally a dilemma. Do I do it right now or tomorrow? Do I push it on to tomorrow? And then, okay, I will just push it on to tomorrow. Am I pushing out? Well, no, I have been coding for 2.5 hours, and that is good enough. That is good for today. I did not stream. I hadn't streamed for some days, and now I have streamed for 2.5 hours. That is good, and I will be streaming the next stream also. And I got stuff. Well, that stuff does not matter, but the thing is, just focus and think as if that streaming the advent of code solution in C is the only thing that I do in the whole day, and think from that perspective, is this a good time to drop off and just drop off? I guess, yeah, because I need a fresher mind to get back at it, which I am hoping I will get tomorrow when I start the stream again. This could be pushing out. Well, it is not. Yes, I can tell that this is not pushing out because it is not pushing out because I can feel things in the brain, and right now does not seem like a good time. Or maybe I'm just fucking thinking too much and I should just stop and don't feel the guilt about stopping this, and I will do this tomorrow simply. Yes, not too much tension. Yeah, bye.